I'm CJ. I work for Kavira. I've been on our CRI, Carbon Ranch Initiative team for most of my time here. And one of the projects that I work on is a grant from the NRCS that has allowed us at Kavira to at least attempt to bring more biochar awareness and technical support into New Mexico. And we've been doing that by holding production workshops where we've brought this big old kiln to a few different farms and ranches and burned materials and made biochar and walked through that process. We've also been writing a technical guide on producing and using biochar in the Southwest, which has been a fascinating experience. And because we had this wonderful webinar week, I also got to get creative and invite some of the people I've met as I work on these different projects to share their depth and breadth of knowledge with us. So that's the stage that we're at today, where we get to hear from Catie Brewer, Sanna, Sevanto, and Rosa, Soriano, who I've had the pleasure of meeting and working with to varying degrees over the last year, and feel, just delighted. And I've gotten to learn so much from even just our brief interactions. Okay, and then let me give you a little more background on everyone, and then I'll let them introduce themselves so that we don't just have to listen to me going at it. Okay. First, Dr. Sanna Sevanto is an environmental physicist and team leader of Atmosphere, Climate, and Ecosystem Sciences team at Los Alamos National Lab. After receiving her PhD in environmental physics from the University of Helsinki, Finland, she expanded her knowledge on biological systems as a postdoctoral researcher at the Department of Organismic and Evolutionary Biology at Harvard University. Before coming to Los Alamos in 2009, she held a university lecturer position in meteorology at the University of Helsinki, teaching atmospheric thermodynamics, fluid mechanics, and environmental physics to both undergraduate and graduate students. In her research, Dr. Sevanto has focused on vegetation-climate interactions, which is fascinating, and vegetation stress responses, with most recent projects aiming at developing methods to produce microbial consortia and improve soil health and alleviate drought stress in plants. So relevant. With over 90 influential peer-reviewed publications, she was ranked in top 1% of most cited scientists in her field by ISI Web of Science. And outside work, you might run into her on the local trails, either coaching Nordic skiing or enjoying the unique multi-sport opportunities in her town. I've clicked away from my video, but Sanna, if you want to give a little wave, just, I guess we all have our names on the bottom. Maybe that's not necessary. Sorry, but there's Sanna. Rosa Soriano is our next panelist. She's an agricultural engineer from Zamorano University with some experience in agroforestry. She's a master's student of natural sciences and conservation at New Mexico Highlands University, which is how I've had the pleasure of meeting her. And she is doing her thesis on the a socioeconomical study of barriers and opportunities for biochar adoption in northern New Mexico. So we've gotten to work together on that, and I'm just going to keep doing it because it's fun. Rosa, would you also just give a little wave so you can say hi? And our third panelist is Catie. Dr. Catie Brewer received her BS in chemistry from Indiana University of Pennsylvania and a PhD in chemical engineering and biorenewable resources and technology from Iowa State University. Prior to joining the faculty at New Mexico State University in 2013, she completed a postdoc at Rice University. Her graduate and postgraduate research focused on biochar characterization and engineering for soil and water remediation application, which I think is so cool. Her current interests include thermochemical biomass conversion, products from alternative crops, management of desert soils, sustainable agriculture, and resilience in food systems. Yay, that's our panel. I'm There's Catie, giving a little wave. Yay, thank you. Thanks for listening to me go on and on for a little bit. So I'm going to hand this off to our wonderful panelists to talk a little bit more about their area of research and its application in the Southwest or New Mexico in particular. And for participants, please feel free to put your questions into the chat as you have them. What we've kind of put together here is if you are asking questions that are kind of follow-ups to what's happening or clarifications, then we'll have we'll try to insert those in the moment. And if you're asking broader questions that are just on your mind that you've brought in to the discussion today, we'll make time at the end so that or throughout so that we can get to everybody's interesting topics. Okay, that's it. That was my part. Now I get to listen. Catie, why don't you begin? Would you tell us about your research? And I think what I'm particularly hoping for is the practical aspect of like what you're looking at, or how, that's the right word, how what you're looking at fits into the Southwest or New Mexico in particular. Please.
Good morning, everyone. The best place to start is probably where my group does, and that is with feedstock. And so my group in general does biomass utilization, which means we have people hand us materials, usually some kind of agricultural or forestry waste, and we help them figure out what to do with it. And we look at it from a perspective of how do we get the most value out of the materials that are there. And so I tell my students when they first start, you can burn anything. So any of the materials that we can get, we could use for fuel. However, that's usually our last resort. We want to try to do other things first. And so we look at first, can we do foods or feeds? Can we do remediation aspects? Can we do value added materials, etc.? And so in New Mexico, I had to learn some new feedstocks. When I first got here from Iowa, I came with a mindset of everything is corn. Knew a lot of things to do with corn stover, a little bit with waste wood. Got to New Mexico and found out I had to change my perspective on feedstocks and therefore the products that were going to be made. And so came to Mesilla Valley in southern New Mexico, and we have pecan shells. Lots of pecan shells, lots of pecan wood. We have cotton gin trash. I had never seen a cotton gin before, but now I'm surrounded by cotton. We have forestry waste, but different than the hardwoods I would have seen in Iowa, and much more of the softwood, the pine, etc. And then we even did one project on tumbleweed because we have an abundance of tumbleweed, plus your usual manures, yard waste, etc. And so we started looking at biochar as one potential application for all of these feedstocks. And when you look at an application, you have to understand what are the properties of the material that you need for that application. And previously, we were looking at char for neutralizing an acidic soil. So soils that have lots of fertilizer application gradually become more acidic over the years. Get to New Mexico, we have the exact opposite scenario. We now have alkaline soils that are salty. And so all the things we used to do or used to look for in a char, we've got to change our perspective. We look for chars that can sequester carbon. And that's the same in both places. So how much carbon yield we can get. But here we started focusing on water. In particular, the ability of a soil to hold water in a way that a plant can use it, which is something that in Iowa and in Houston, I hadn't really worried about. You make a biochar, you put on the soil, there's plenty of water. No particular reason to measure it, except for maybe drainage. Here, we want to hold on to that as strongly as possible. And so you have to change not only the feedstocks that go into the reactor, but also what you measure on the way out. So where I used to measure nutrient retention, I now measure water retention. And so I've been trying to understand how our feedstocks, what unique characteristics our feedstocks have, What unique needs do our soils and agroecosystems have? And how do we use our conversion technologies in between to make those two fit? And what I've learned in my, it's my 10th year here at NMSU, is I've learned that there's not nearly as much known about the kinds of soils we have in New Mexico as there is in much of the rest of the world. There's just not a lot understood of how the chars are going to act, what things they're going to affect, and how it's going to affect the crops that we grow here. And so what my group has been working on is understanding some of that feedstock char crop interaction, but also what other things we can do with the char if it's not ready for soil application. Something that many char researchers have encountered is an economics issue. We can make char, we can make lots of char, but we don't have a lot of people who can pay a lot of money for a lot of char, at least not for putting it on the soil when there are benefits that we don't understand or can't quantify yet. And so my group has also been working on how chars can be used for water remediation projects. So we know from char research that the char can have metals or organics or other contaminants stick to the surface to pull them out of water. And so we've been doing the same exercise of what feedstocks do I have? What reaction conditions can I use? And then depending on those things, how well does it attract or not a material in water that I want to pull out? And so my group has done some work on heavy metals. We've done lead, we've done copper. We're about to get started on to arsenic, which should be exciting. We've done a little bit of trace organics and nitrosyl dimethylamine for those who like a mouthful of chemical name. And we've also done some work on, turbidity and just general, and we've done a little bit on nitrate, not much, but a little bit on nitrate. And so that's what my group has been doing over the last couple of years. As we see more projects coming into the funding agencies to deal with carbon management, we've seen the interest of char in the agroecosystem go up, not just for the managed fertilizer, managed water, that interest was there before, but now also manage carbon as a whole system. And so that's what my group does. So most of my group is chemical engineers. We're only happy when we are putting things into shiny steel reactors and attaching numbers to everything that we can put in our calculators. And then we collaborate with soil scientists and plant scientists. If there's one main lesson I've learned in the 10 years I've been here, is that chemical engineers should stick to what they're good at with the reactors and probably not be in charge of growing plants. Plants are usually not our strong suit until they're dead. And we're very good at making them that way. So that's what my group does and some of the stuff that we've been looking at in New Mexico.
Thank you so much, Catie. Rosa, would you like to pop in next? And just as a reminder, because I know we were all just listening to Catie, please tell us about your research. And I guess your research is happening very specifically in New Mexico. So I guess that application there is really built in. But yeah, please share with us what you're up to and what.
Yes, thank you. Well, I'm from the Dominican Republic, and I have a background since I started my studies in agriculture, and I was focusing vegetables production. And I spent, before coming to Highland or before going to the Dominican Republic back after my bachelor, I spent 1 year working with science. And it was fascinating, the job. It was in Nebraska. And as Catie said, it was a totally different environment. There is corn and soybeans also, and that's what I've been learning. But somehow I feel disconnected with that job because my focus was pretty much on pesticides. And I don't know, I felt that I needed to do something different than that. And that's when I decided to go for agroforestry. And I spent 2 years in the Dominican Republic working in a cocoa project. And then I feel more connected with the environment, and I feel more this need to look for different ways for environment conservation. And I found this master in New Mexico, and I just decided to come. It was amazing. And it's a fully different environment, the Southwest. I'm coming from vegetables production, rainforest, and to come to the Southwest, area different. And it was fascinating to get in contact with Eva. I got in contact with her before coming for the master's, and we got this idea to, knowing that biochar is being studied for many years in the, as Catie mentioned, in the chemical aspects, in the different application aspects, the uses and the impact on the soil. We also wanted to understand in the Southwest, what is the willingness of the landowners to implement the biochar as their land management strategies. And we've been looking for information and type of research that will be focusing on the social aspects, because before any technology adoption, there is the need of awareness. And if the people is not aware of what the innovation is and what the application is, they won't be willing to implement it or to adopt it. And that's what we are looking for, like to understand what are the land managers' barriers to adopt biochar and what opportunities we have coming from their perspective, beyond then the different other research that are being done. And we started collecting information since February. And in the past summer, I've been conducting some interviews. And yeah, it's interesting, everything what we've been learning. I think we are going to discuss a bit more later. And that's my research.
Thank you, Rosa. And Sanna, would you also share with us what you've been up to? And
Yes,
in New Mexico. Thanks.
Yes, I'm happy to do that. So I have been in New Mexico for 13 years. So as you heard, I'm originally from Finland, and their soils are very different than from here. There is no problem with water, and everything is like peat. And in my career, I have actually worked mostly with vegetation atmosphere interactions and a carbon and water cycle in ecosystem scales. My group is interested in climate impacts on ecosystems, ecosystem impacts on climate, measuring greenhouse gases, measuring influences of people's actions on systems in a large scale. We also do conduct greenhouse experiments with plants. My most recent interest in this one has kind of turned from just observing how climate influences vegetation and how do plants die when it gets really bad, like plant stress responses. It's come to the side of like, okay, can we do something to help the plants? And that's where the biochar and the soil quality and the microbiomes come into the picture. So my latest project has been on developing a systematic method to try to produce microbial consortia that can influence plant drought tolerance. And we have actually been able to show that you can do that, and with a fairly simple directed evolution protocol. And you get microbes that can influence, for example, when the plants close their stomata during drought, which influences how well they grow with less water. And the challenge with this kind of applications of using microbes for improving plant function is that, okay, we can do it in the lab. We did it in the greenhouse with an artificial soil that was sterile. But what happens when you put it out? And that's where the biochar comes into the picture. That is a potential good carrier. There are different things where Catie's expertise would be really heavily needed about like how to engineer it so that the microbes can live in it and be used. But that is one of the applications that is very interesting. And as a person who has worked a lot with plant physiology and interested in plant survival, I also see the biochar here as, especially in New Mexico, as a very important soil improvement material if we want to get larger areas used in agriculture or growing any kind of plants. And the climate effects of this kind of a change in landscapes could be huge here, because the vegetation influences the water cycle as well as the carbon cycle and can create a positive feedback where we can actually influence our own water tables here. So that's part of the interest of mine in looking at different solutions of changing or managing landscapes in a sustainable way. And in this aspect, I have worked with biochar a little bit in an agrivoltaics project where we are trying to develop methods of growing crops under solar panels to combine food production and energy production and the benefits of those together in our climate.
Awesome. Thank you, Sanna. I think that I'm going to stick with you for a moment and we'll kind of like move backwards. The first question that I wanted to ask you in particular is about the relationship. If you can talk about the relationship that you've seen between biochar in the soil and above ground plant characteristics.
Yeah, so yes, so in I went through a little bit other literature about that too, because we got the questions beforehand. So what we saw in our own experiment is that when we grow tomato under solar panels, the tomato that gets the biochar with compost, as opposed to compost alone, they grow faster, they grow bigger. And that was the effect we got. We didn't get that same effect when the solar panel shading was not in place. So I don't know exactly how the interaction there is and what works. Our experiment was a very small one, so it requires more studies to understand. We did this one in a solar panel site in El Rito at the Northern New Mexico College. That soil is not cultivated before. It is an old arroyo bed. So we basically created a plot with compost and biochar where plants could grow, and the tomatoes grew really well. But that was kind of the effect on the growth. The other impacts on the environment that come from the literature and knowledge of environmental physics is that the biochar can definitely influence the hydraulics of the soil. And here I see it as a very, very important factor, because runoff is a very big problem with us. In many other places, you have to make sure that your fields are not holding the water too much and it's going around. Here, you, as Catie said, you have to hold onto the water and try to keep it there. And one problem is that our soils are so high clay content. So everything, when it rains, the water doesn't penetrate the soil very deep. So the biochar definitely helps. That's what we see in our results. It helps with that. It also aerates the soil or produces pockets in the soil where the plants can put their roots deeper. And that could be one reason why our tomato plants grew better with the biochar, that it allows more space for the roots, because generally plants don't like if their roots are pushed too much, or if they are too packed or too inundated with the water. So those are a few things that we have noticed. And one interesting thing that we were looking at the results yesterday, we also see that there is a slight temperature difference in the soil that has biochar that doesn't have. And that makes sense because the biochar is an organic material. It can change the heat capacity of the soil and the heat conductance of the soil, and that can influence things. And whether it is a benefit or not for the microclimate around the plant depends on how you mix it, what you mix it with, and how much do you use the original soil there, and because all the color of the soil and what you do influences the albedo and the absorbance of the radiation coming in, and also the heat transfer properties in the soil. So it is a complex system, and there is a lot to study. But yeah, there definitely are effects that can be very positive.
Thank you, Sanna. And I'm what you were saying made me think about some of the things that Catie opened with when it comes to like the impact of what the biochar is made of, where the feedstock comes from. And so I wonder if you know what feedstocks made up the biochar that you used in those experiments.
I think ours was based on some kind of wood, but I'm not sure if it was based on like waste from construction or natural.
Okay, thank you. I think I'm gonna pop over to Catie to kind of stick with that like line of thought. Catie, can you talk about matching biochar characteristics with intended land stewardship outcomes? Some of these things that we're hearing from from Sanna and how to connect those ideas.
I'm going to pick up with what Sanna mentioned about microbes and about water, which is very different in terms of characteristics that you would want for something like an activated carbon used to treat water. So when you treat water with an activated carbon, the goal is to get as much surface area in your material as possible, so there's as many places for stuff to stick as possible. And so when we make a char for activated carbon uses, we want to have lots and lots of really tiny holes, because lots of really tiny holes in the material creates the most surface area. When you get to microbes and to water, you don't want little tiny holes, because the water won't go in there. Or if it does go in there, it gets held so tightly that the plants can't get it out. And if you have holes that are too tiny, there's not enough space for the microbes to live. And so when we're thinking about chars for soils here, where we want the microbial activity, where we want the water retention, we're going to want to make chars that have bigger holes. And so the way that we do that is we find feedstocks that have cells that are about the right size. And so when you look at most of the pores in biochar, and you compare them to a picture of the plant cells, they're essentially the same size. All that happens in pyrolysis is the innards of the cell break down and volatilize out, leaving the shell of the cells behind. And those plant cell sizes are just about right for holding water at a plant available level, and are just about perfect for high occupancy microbe apartments. Now, people who look at biochar quality always ask us, but the surface area is so low, how can this be a good char? It's like, well, the point wasn't the surface area. I'm not going for absorption. I'm going for the right size of spaces to be occupied by water or microbes. And that would be a big difference between how we process the char. If I want high surface area and lots of little pores, I got to go to high temperatures. I got to hit it with a little bit of oxygen. If I'm just looking for using the plant cell built-in compartments that are already there, I can get away with lower temperatures, longer times, typical of the types of things that you would see in some of those kiln-made biochars, as opposed to some of the lab-made biochars at the much higher temperatures. And so that's one of those things where we have to understand every process we do, what effect does it have? And just because it's good for one thing doesn't necessarily mean it's going to be good for the others.
Fascinating. Wow, thanks. When you say well, actually, yeah, when you're talking about the plant cell sizes and having those be the appropriate pore size, is that like any plant?
I don't. Now, I am not a plant physiologist, and so I'm probably going to put my foot in my mouth here. My understanding from looking at dead plants, and again, I don't touch the live stuff. Save that for people who are good at it. They all seem to be about the same size. Now, some of the ones, especially from wood, can come in really strange shapes, those super long cells for transporting materials. But in general, they're on the size of the micrometers kind of thing. So bigger than the nanometers, smaller than the millimeters, that micron size is about right. And correct me if I'm wrong, Sanna, but most plant cells are on that same order of magnitude.
Yeah, you're absolutely right. And I was happy to hear your explanation for all of this, because it just supports the choice we made in what biochar we actually used in our experiments, and the plant cell size. That all makes complete sense to me. And I didn't realize the differences in the biochar that tries to attract pollutants versus this, but yeah. And our biochar was made by like non-high heat combustion, so yeah, and wood material, which worked really well.
And if you measured the surface area, you'd probably find it was really low, and this would be a
Probably.
concern, and then
Yeah,
it still works.
yeah.
Yeah, and part of what I'm hearing and what you're saying is that there's a good reason for folks to like rely on their own kiln made biochar as opposed to really high heat production, which I'm drawing extra conclusions here, but if I really love the idea of tying the whole system together to be able to deal with wood waste on one's own land and manage fuels and fire risk at the same time. And if that and making biochar in a kiln at, I still don't know exactly what kind of temperatures we're talking about when we're talking about fire at a low temperature. That doesn't totally register for me, but like if we're dealing with lower temperatures in an outdoor kiln as opposed to like a fully enclosed kind of something.
I do have to put a note of caution in here as an engineer.
Yeah.
As long as you get it hot enough, you don't need to go super hot. And what I tell people to look for, your kiln is hot enough when all of your char comes out black. If it's coming out brown, it's not hot enough, or it was hot enough but not long enough. And so you do have to worry about undercooking your char, but as long as all the char comes out black, you've probably reached that high enough temperature to be good to go. And Rosa, what were you going to add to that part? You would start to say something
about the oxygen, that at the end that is influencing also the end result. But makes sense. Black is a good point.
Black is a beautiful color whenever you're talking about char. That's what you want to see. Not gray, not brown. You want that nice shiny black.
And Rosa, what you were adding was about like how much oxygen gets in there. Is that like impacting the outcome or how hot it gets?
Yes.
Okay. Yeah, that's what I think. I'm new at all of this, but I think that's what we were like, yeah, finding in the difference between some of the different types of kilns, that if they're sealed at the bottom and so no oxygen is coming in from underneath, that it gets very hot very fast. And while you can use like a smaller setup, like you can make biochar in a pile, you don't even have to use a kiln, but it takes longer. There's more ash. It's not as it doesn't get, I don't know, not as efficient. I guess it's not as not getting there as quickly. Yeah. Wow. I'm learning so many things now. I understand why. So this is wonderful. I feel like I'm continuing to be convinced that biochar is a great idea. But I'm interested in, Rosa, in you adding in some of the things that you've learned as you look at like challenges and opportunities with these ideas.
Sure. Well, I think it's unique in the Southwest, as Catie mentioned also before, is that we have a lot of biomass available because there is a need for fire prevention. And the land managers, they need to perform those thinnings each year or each certain time. And some of them have a good market for biomass, but there is a lot of slash that are low value or no value, like for the market. And then we have all this availability of material to create biochar. And there is then the issue that this biomass can be fuel and can help wildfires. And what we want to know is like if land managers are willing to convert this biomass into biochar. It could be for market, but it also could be to apply on site. And they are reducing fuel from the forest, but they are also improving the health of the soil. And what we've been hearing from the landowners mostly is that they don't know about biochar benefits. Like as Catie say also, there is sometimes they know that it could be good, but they don't know how good it is. I mean, how to quantify those benefits that they are going to have from applying biochar. And also they don't know about biochar production, how the production is being done. They can find some information online, but they are like looking for more specific and contextualized instructions. And that's kind of one big barrier, that not knowing how to produce biochar. And then some other people that knows how to produce biochar, they consider that it's very labor intense. And most of land managers, they are not willing to do extra work if they don't have some incentive. This incentive could be money or support from agencies, or could be like having being sure or having I will say the confidence that what they are doing is going to have a good impact on the short time. And all those things are like, we as educator or scientist or researcher, we could know, but those impacts can take time. And I think those are, and also access to equipment, that which is related to the money or the cost to get equipment to produce biochar, is also one barrier that most of land managers are bringing up.
CJ, it looks like we have a question from Ed. He was asking, so am I hearing that biochar and activated charcoal are the same thing, just with different pore size?
I'm going to take this one. I'm going to give you the engineering answer that my students absolutely hate. It depends. And so biochar is a product of pyrolysis made from biomass. And I put that, you've heard this many times before, I'm going to put that out there first because I have to contrast it with activated carbon. Activated carbon is a carbon-based material that has gone through 2 steps. The first step is pyrolysis. The second step is activation. Activation is usually a higher heat or higher chemical intensity partial oxidation. And activated carbon does not have to come from biomass. Activated carbon can be any of these carbonized materials that have gone through an activation process. And so many of the activated carbons you see in the store some are based on coal. So you start with coal, you pyrolyze it to make a coal char. Then you put that coal char through say a steam heat treatment to increase the surface area and punch a whole bunch of tiny little holes in it. You could, most of the activated carbons that you'll buy for like your Brita filters, those are made from coconut shells. So they take coconut shells, they do the initial pyrolysis to make coconut biochar. So in that case, it's biochar. And then they put those biochars through an activation process. And so when I hear activated carbon, my first question, okay, I usually have many questions. My first question is, what was the original base material? Was it a biomass? Was it a coal? Was it some kind of, you could even do this with like really thick petroleum products, like the asphalt materials. You could put those through pyrolysis first to make a carbon material and then activate it. So whenever you hear activated carbon, start with what was the base material, which could have been a biochar. And then I ask, what was the process? What was the activation process to reach the final properties? Does that help? Okay.
Wow. I didn't know we were going
They'll
there.
never look at a fish tank filter the same way.
Something that I'm interested in hearing, I think from all 3 of you on that is only coming up with me as I'm hearing what Rosa's saying is, Rosa, you talked about there being biomass that needs to be dealt with, and I think most of the time when I think about that, it's coming from the perspective of pre-wildfire space. There hasn't been a huge wildfire, and so we've got all this material and we want to prevent a catastrophic wildfire. So how do we mitigate the amount of fuel that's available for that? But while you were speaking, I also was thinking about the folks who are dealing with the aftermath of wildfire, and just the fact that there are still some unburned materials there. And there is one of the questions that I've been trying to navigate, and I'm wondering what input there is in this group is like, what is the char? What is the charred material that is left after a wildfire? And then like you may have to extrapolate some stuff, Rosa specifically, but like what might you see as some barriers or potentials based on what you already know to land managers taking leftover unburned material that isn't perfect for lumber because it's been somewhat burned, so it can't be used in some other financial way, but is there potential for that to be used as a feedstock? Yeah, I'd love to hear what any of you think about that.
I've been in contact with some landowners that they already do that. They already like take this remaining wood unburned, but there is others that always come with the issue of labor, that they don't have. It's like hundreds of acres and they don't have labor enough to do this process, like collecting, transporting, mobilizing, and I think that's a common issue that comes each time that we speak with landowners, is like the extra work that they have to do for that, but the ones that have the possibility, they already do that, so that there is people that is aware of the different uses of the biomass even after a wildfire. That's what I got from conversations with landowners, but like I'm not a, I have a full different background. I just get what they tell me and like learn from that.
Catie, what about you? What do you think about the post-fire situation?
I'd say it'd be great to use, as long as it was clean natural wood to begin with. Go ahead, but I've also heard the same thing on the farm and the greenhouse side. Even some people who are interested in it, they look at the amount of work they already have to do and the labor shortages they already face, and the thought of trying to add one more step is too much for many of the people that I've talked to, especially if they know that the benefits are going to be seen in the next 10, 20 years, and they've got to be thinking about the next 10, 20 months.
Totally.
That makes so much sense. Yeah. Sanna?
Yeah, I want to bring up a slight different aspect here, because we have been talking about this burning and the effect of burning on the material. From the climate side, the forest fires, if they burn really, really heavy, like hot, they produce char and it's black. But if they don't burn that hot, they produce debris that is brown or half burned or something like that. And from the carbon balance perspective, basically the material that is not fully burned decomposes faster than the fully burned material or the black char, because there is more organic stuff. The microbes need for them to attach, and that is one of the challenges in using biochar as a carrier for microbes, is that there is very little things for the microbes to eat at first. And because the microbes are most eager to eat easily available sugars, and that's not the lignin in the walls, or the burned lignin in the walls. So that's why biochar, when it's actually burned properly and applied properly in your system, it can mitigate or not increase CO2 emissions from the soils as much as some other organic materials, because it does not decompose as fast. But then if it's not burned that way, then the decomposition process can increase the CO2 emissions. So yeah, from forest fires, the CO2 emissions when they are burning is bad. But then if they are not burning hot and the material is left there, the decomposition, if it's not fully burned, it produces more CO2 and happens faster. Although in New Mexico, I have to say that here our climate is so dry that decomposition in general is very low or slow. We can see wood trunks in the forest that have been there for 50 years and they barely look like anything has happened to them. And that is very different in more moist environments. That's just an aspect of the burning and not really about the farmers using, but in that sense, the farmers, if they can use the half-burnt material to produce biochar, that could be actually a good climate act, like reduce or change the carbon cycle so that you could benefit from it rather than just decomposing things in the natural system.
I'm just being reminded of Catie's input about like what comes to mind when you hear biochar. It's like complex. There's a lot going on. A lot going on.
I agree with that.
Okay, so where am I in my list? Oh, okay. Oh, ooh, I think I'm gonna
Yes.
force
There is
myself.
a question in the chat from Kennedy. Just a second, let me open the chat. Here is asking, is that why some biochar is inoculated with compost tea to feed the biology? And
Yep.
yes, it's totally because microorganisms actions is slow and there is less micro because sometimes the soil doesn't have enough pores for the microbes to be and doesn't have enough water for the reproduction or enough nutrients for the microbes to get to feed. So that's a good way to enrich the soil, like when you inoculate it, the compost with some fungus or some nematodes or whatever.
And I would like to add to that one that basically, if you want to try to convert an uncultivated piece of land in New Mexico to a field where you grow plants, biochar alone will not do it. You do have to put compost with it and more other organic materials because the organic material content of our soils is tremendously low. It's between 3 and 4%. And just not enough to maintain the growth or microbiomes and the plants there and nutrients. So that's something that if you start using biochar, make sure that you have other organic material in your soil as well.
I so want to back up what you're saying because char is a carbon sponge, but most things can't eat that carbon sponge, and so they still need everything else, and microbes do not live on carbon alone. And so what I tell people is if you're going to grow plants, make char a component of the organic matter that you're putting on the soil. But by itself, you're right, the soil would have to have a lot of things already in it for the char to make a big difference.
And what is interesting in that realm is that in our experiments, we used a mixing ratio of 1 part biochar, 20 parts of compost. So it's actually a very dilute, and it still has an effect here. But then I talked with colleagues about this in Finland who are studying biochar there. Their soils are black, very rich in organic material, very moist. Biochar does nothing to them. And that is kind of the environment interaction because their soil is already good enough.
We had the same thing in Iowa. You take one of the best soils in the world and you make it better, it is really hard to see a difference. Whereas if you start with a not so good soil, the smallest changes make a much bigger difference.
Wow. This is fascinating. I'm wondering if you can if anyone can add something about like chemistry in here. Like I'm thinking about not just, well, I'm thinking about pH because that's the one thing that like that biochar I know like kind of brings us in the direction we don't really want to go. But if you're seeing improvement in plant health or growth, how does inoculating or how does the compost impact what the biochar is doing? What would happen if you put biochar out without compost? Like, can we go there? Sorry, I'm off script already.
I can take a stab at this if you want. So most of the pH effects of char come from the mineral material that's in the char. And so if you look at a plant material, it's usually slightly acidic on its own. And depending on the minerals that are in it, especially the alkaline earth metals. So plants need calcium and magnesium and potassium for plant nutrition. And those, once combusted, form alkali metal salts. And so the amount of ash, usually the higher the amount of calcium, magnesium, potassium ash, the higher the pH. Now, if your ash is made out of silica, like sand or dirt, that's going to have a fairly neutral pH. And so the higher the ash content of the feedstock, usually the higher the pH of the char. Now we have soils that are already fairly salty and are already fairly alkaline. So the soils already have a pH of 7.5, 8, 8.2, somewhere in there. And many of them are borderline saline, especially down on the southern end here. I'm not as much familiar with the soils on the northern end. And so if you're adding a char, you don't want to be adding the same calcium, magnesium, and potassium minerals that are already overabundant in the soils. Now, when people put in compost, there's a couple things that cause the mitigation of pH. Compost on its own is usually neutral to slightly acidic, and you mix that with a material that's neutral to slightly basic, and you get extra neutral. So that can help. Also, when you're adding compost, you tend to water your compost or rinse it in some way, and the act of rinsing removes some of those alkali salts from the char. And so when we have a really salty char or really alkaline char, we tell people, give it a water bath, drain off the water, then check the pH again. And many times the pH of that char will go down because you've washed away those alkali minerals that have been causing the pH increase. Does that help a little bit? In tropical regions that are very weathered and very acidic, when you add char to the soil, you're replacing all of the calcium, magnesium, and potassium salts that those soils have lost. In New Mexico, we've got young soils. They are loaded, especially with calcium. At least down here, we've got, essentially chalk in some places. And so we don't need a lot more of it. But that's one of the big challenges is we have to balance stuff that comes with our feedstock versus what's already in the soil.
Yeah, and I would like to add to that one a couple of aspects. Here in the north, we have the same problem as in the south, the northern New Mexico. The soils are very alkaline. We don't have the saltiness as much, but the alkalinity is a struggle. And that's why the compost is very important, because most plants don't like alkaline soils. There are some who are specialized for it, but they are not. and so making the soil neutral or slightly acidic helps. What is nice if you add compost that has leaves, and especially pine litter, that makes it more acidic, and that helps things there. The other aspects that I find fascinating in this one, looking at the greenhouse gas emissions from agriculture. One big greenhouse gas that comes out from agriculture is nitrous oxide, N2O. It's 200 times more potent than CO2 in the 100-year time scale. And that is about like how long does it stay in the atmosphere. And the emissions for that come from over-fertilization, and they come from like the different aspects of the chemical cycle, nitrogen cycle in the soil. And there are some studies showing that in certain conditions, the biochar can actually reduce the N2O emissions from the soil. And they haven't been studied very much for the alkaline soils. So that is something I would be really interested in getting some experiments going on here in New Mexico looking at that. I don't know, Catie, if you know more about the studies here on that topic.
Nitrous oxide emissions, no, but I'm just thinking after this webinar, we need to talk.
Yeah, we need to talk. We need to get a project going. but yeah, so that is and yeah, nitrous oxide. And the other aspect is basically because our agriculture usually over fertilizes the plants, because we don't know when the plants have had enough nitrogen. There is no easy way to measure it. You actually have to take a sample and take it to the lab, and it's expensive. So people use over fertilization, and then you get that's what increases the extra nitrous oxide emissions. So if biochar could help optimize the fertilization and hold on to the nitrogen, that would actually be a big thing.
So just so that I'm making sure that I'm following all of these things, is there ever a time in New Mexico or like soils like the soils found in New Mexico where biochar by itself would be appropriate? Or is it always does it always need some kind of inoculation?
It can help on its own, but it may not help nearly as much as it would have in combination. And I'm going to put a special asterisk on that. If you have a char that's alkaline, and if you have a soil that is alkaline and likely to have micronutrient deficiencies, making that soil more alkaline can lead to signs of nutrient deficiency in some of the plants. We had a case, we put some char in a soil in Farmington, and that soil was around a pH of 8. We added more char. It was wood char, so the pH wasn't too high. It was like 8 or 9. And we noticed the plants experiencing iron deficiencies because the addition of alkaline char to slightly alkaline soil changed the chemistry of the iron. So the iron was still in the soil, but was no longer available to plants. And so that micronutrients is something we don't yet understand. We're about to start a project now about char's interaction with the micronutrients and with heavy metals. But we don't have a lot of good answers, especially on the alkaline soils. Everyone studied the acidic soils. There's not nearly as many studies on the alkaline ones.
Yeah, more studies in New Mexico. That's what I'm taking away. And that leads me to,
yeah, I could just quickly add to that one that despite all this, like knowing, and how Catie also put it, like if you have already really good soil, making difference is hard. So that's the reason why I actually see this Southwest region as a really potential beneficiary from biochar, and using it here makes way more sense than in many other areas.
Yeah, that makes a lot of sense. Ed also just asked, is there a time when biochar may be detrimental? Is it possible for the biochar to absorb and hold nutrients, starving the plants?
Usually the things that starve plants of nutrients are the microbes. So if you have the same soil and plants and microbes both benefiting from it, because microbes can get more places faster, microbes usually win. And this is usually a problem with nitrogen especially. So we always worry about putting down carbon that's easily digestible, because the microbes will eat up the carbon, they're starving, and they'll take all the nutrients around. This is nutrient immobilization. And that's why it's important to have your char all the way cooked. And so in terms of absorbing nitrogen or phosphorus or potassium, I don't worry about the char taking those things away from the plant. I worry about the microbes that the char might influence taking those away from the plant. So that's where a properly cooked char is important. In terms of micronutrients, the iron, the zinc, the manganese, that's something we don't understand as much. We know that char can have a pH effect. We don't know about the absorption effects. That's one of the things we're trying to study. I haven't seen too many cases where a plant is going to starve outside of what the microbes are doing. But again, those are some questions we have not answered yet in any quantitative way.
And I would like to add to that one aspect of potential mitigation for the nitrogen part. And I have not tested this, but what comes out of our research is basically that New Mexico forest soils actually naturally contain nitrogen fixing bacteria. They have algae that fixes nitrogen too, and a lot of nitrogen fixing bacteria, much more than already cultivated agricultural soils. So one way of trying to mitigate this microbes eating up what the plants could do, if you see that, could be that you actually bring a forest microbiome, a little bit of forest soil into your system, and you rejuvenate it with the nitrogen fixing bacteria.
Cool.
But I don't know how the nitrogen fixing bacteria interact with the biochar. That hasn't been studied.
I have not done it either.
Something else to study. I'm so excited. This is another, like, we've really gotten into some of these questions of like, what is it that we're really interested in learning here, and what what don't we know that like pretty specifically to New Mexico or the Southwest, that like so much research comes out of the northern part of the United States when it comes to agriculture, that we learn a lot more about acidic soils. And so one of the other questions I have is to ask Rosa if you've got anything you'd like to add when it comes to what you've been learning from producers or land managers about what questions they have and what other things we've like that you've become aware that you'd like to see studied, or that's I think those are all the words I have for that question.
Well, I think what Career Coalition is doing is great and is pretty aligned with what land managers are requesting, because most of the land managers, they are like pretty willing to attend to in-person activities. They really like that because they feel that they can learn and understand faster and better on doing things on the practical skills, on the practical application, sorry. And something that they request and they say that they will be glad to have is like a worksheet or some like specific instructions, like, and for me, this is pretty much like what they are requesting is pretty much like the work that Career Coalition is developing. And other thing that they mentioned, that they feel this connection between agencies or organizations that are working, promoting biochar or promoting more sustainable technologies, that they feel that sometimes it's hard to see that. I mean, the same land manager can see like different institutions are working for the same, but they are probably not interacting in between. And they feel like if institutions can get together, they are going to be stronger and they are going to probably be able to reach more areas and more people. And using also channels that landowners are used to already, like water and soil conservation districts. So I think that's what they are like requesting the most, and for me it makes a lot of sense. I don't know if that it was like your question or if there is something else that I didn't get. Sorry.
No, I think very open-ended. I was interested in knowing about what questions you've heard from producers about what they're
how to produce. Yes.
Yeah, how to do it.
Yeah.
That's fascinating. Yeah. And then I wonder too, from like Catie and Sanna, if like what that brings up for you, like if people are asking about how to produce it, what from your perspective would be relevant to share with folks who are planning on producing biochar on their own from the things that you've learned.
There's a couple of things that I tell people when they first ask to watch out for. And one of them I've already mentioned, and that is the color of your char. If it's brown, it's undercooked. If it's gray or white and ashy, it's overcooked. Ash usually means you had too much oxygen getting into your system. So the level of doneness is one main issue for producing char, especially a good char. Another concern that I typically have is smoke. Anyone can make char. It's a matter of how much smoke are they going to put into the atmosphere while they do it. And so much of the reason to have a kiln, especially kilns that have been designed to burn off the volatiles as they're produced, is to reduce the amount of smoke. There are some kilns that will smoke a little bit when you start them, and then after that, all of the smoke passes through the flame front and gets broken down. There are other, one of the big dangers of just digging a pit, filling it with wood, lighting it on fire and covering it up is there's no mitigation for the smoke. And that can be hazardous for the people around the pit tending it. And so I tell people, whenever you're going to do, the reason to look into a kiln design, a lot of that has to do with smoke management, oxygen management, making sure you get the right amount, not too much, not too little, and then being safe around heat. This stuff is hot. I know my temperatures in Celsius, not as well in Fahrenheit, but none of it is what you're going to want to be touching. The other heat hazard has to do with the char after it's made. There's a reason we use char for fuel. Once you get it started burning, it burns really, really well. And so if you've made a pile of char and you have it sitting there, you have to manage its first oxidation. Let me explain what I mean by that. When you're in a pyrolyzer, you've removed all of the oxygen from the system and all the oxygen has come off of the surface. And so you've got these surfaces that are just carbon and hydrogen. Now, as soon as those are exposed to air again, the oxygen from the air is going to go down to the carbon surface. You're going to have these tiny little combustion reactions as it forms a carbon-oxygen layer on the very top surface. Now, if your char is nice and cool, those miniature combustion reactions create a tiny amount of heat, but nothing else happens. If the char is already hot and you expose it to oxygen, those little tiny combustion reactions are going to go faster and stronger and produce more heat and eventually start a fire on their own. And so one of the most dangerous types of char is the fresh hot char that's just pulled out of the pyrolyzer. So many people, when they use a kiln, when the reaction is done, they'll take a hose and they'll douse it with water. And this addresses most of that issue. It gets it wet, it gets it cooler, and it helps form that protective oxygen layer on the surface of the char. If you're making it in an environment where you don't have the option to dunk it, get it super wet, you have to make sure that it's all the way cooled down before you expose it to oxygen. And then as it gets exposed to oxygen, you have to be prepared to cover it and cool it down. And so how this looks in our lab is we have a pyrolyzer. It's about size of 2 or 3 2-liter bottles. And when we're done, we have nitrogen flowing through that. So there's no oxygen at all. When we're done, we leave it overnight to cool under nitrogen. So the char is all the way cold before we empty the reactor. Because if you open up that reactor when it's hot, you will have a fire in your laboratory. Ask me how I know. We've done this a couple times. Don't do that. I have them cool it down overnight before they take it out. And then we have a paint can sitting nearby because we know we're making this much char. So not a big deal. When we take it out, I tell the students, keep an eye on it. If it starts to smoke or starts to get hot, dump it in the paint can and pop on the lid, just like you would stop a kitchen fire or a grease fire. And so when that new char is first exposed to oxygen, be really careful about the self-heating. Because again, char's a fuel. It's a really good one. We only want it to be a fuel, though, at intended times and under intended circumstances.
Yeah, and from the climate perspective, I want to reiterate what Catie said. How you do it matters. If you are really concerned about the CO2 emissions, and you want to reduce that one, then you need to use a kiln and optimally capture your CO2 for other use, because the burning does produce CO2. And even if the biochar, if you put it into your soil, could actually reduce the greenhouse gas emissions. But there again, it matters how you do it. And there are not quite enough studies, especially in the alkaline soils, like Catie mentioned, that on the effects of biochar on greenhouse gas emissions. It is potentially a benefiting agent. It can mitigate. If you get the plants growing well on your new field, yes, the plants take up carbon and you benefit the carbon cycle. You might be starting to extract more than you are producing and getting a negative carbon balance. But the production of the biochar does produce CO2 as well, and how you do it matters. And it also matters how you apply it into your soil in terms of the greenhouse gas emissions coming from the soil and all the soil properties and soil chemistry as we discussed. So depending on what are your goals and what you are interested in, how you do it matters.
Excellent. I'm so glad to know these things because I feel really good about the process that we wrote out in the workbook. So for people who are interested in following Catie and Sanna's guidelines there, that is going to happen. Okay, and I want to, Ed's got a question in the chat, which is great. I want to take a pause from my own questions and just see if there are any other questions that have come up from other participants. So we'll take Ed's question first, and then if other participants have something to say, please, if you can use the hand raise function go with that. If you want to put something in the chat, you can do that. You can put your camera on and just give us a wave if you've got something that you want to ask our panelists. Ed's question is, what should we look for in a commercially available biochar beyond its doneness? I'm guessing that means like beyond just being the right color. Okay. Yeah, what are we looking for?
I would ask two questions of whoever I'm buying it from. Well, besides how much does it cost? Because there are some people who will sell you char for an awful lot of money. Most of that extra cost is probably not helping you much. So first one is that one. I always want to ask them, what did they make it out of? And if it was made out of, your yard waste and your organic materials and your wood and all that, I'm not worried. If they say it's been made from something like reclaimed wood or municipal solid waste, or any of those things, that's when it starts. And if they can't tell you what it's made out of, that should be another red flag. They should be willing to tell you what it's made out of. With regards to the reclaimed wood and municipal solid waste, the thing that we're worried about there is usually metals. Either things like copper or arsenic that were used to treat wood that's used outside to prevent microbial growth. If it's municipal solid waste, it could be any of the range of gamut of heavy metals could end up in there. And so make sure you start with a clean feedstock, that they know what that feedstock is and they tell you what that feedstock is. I would also look for how much the company has participated in biochar certification programs, which require a certain level of testing and reporting. And there's the International Biochar Initiative's biochar standards. There's a set of European biochar standards. And I'm less concerned about which standard it is, so much as they know that there are standards and that they are participating somehow.
And I just reiterate with what Catie said in the beginning, looking at the a little bit of the surface area as well, because if you have a really high surface area char, then it will not help the plants as much.
Cool. I have a desire to just be slow enough that anyone who has been in process of trying to get a question into the chat actually has time to do that if there is anything there. But the next thing, if we don't have any other questions, the next thing that I would like to do is ask our panelists just for, is there anything that you were hoping you would get to talk about or that has come up in your mind as we've been talking that you'd like to touch on or share that I haven't asked about? Which does put you on the spot immediately. What do you think, Catie?
I just know that I need to make more trips to northern New Mexico.
You're welcome in this side. Well, I wanted to know, like, if in any of the workshops that Brewer Coalition is organizing, people is asking about those incentives, because I know the NRCS has this Biochar amendment incentive. Do we have information? And I've been looking for these for myself, for my own learning, information about how do people apply for it and what is actually that incentive? Like, do we have this information, or do we have this information in hand to provide to the landowners who have curiosity about? And if there is any other incentive besides that from the NRCS?
Yeah, over the last whatever, it's October, so I don't know, 8 months, my awareness has shifted from, there was an NRCS interim practice that had been approved in some states, that had been approved in some states to allow people to apply for funding to apply carbon-based amendments on their soil. And that is separate from applying for funding to create carbon-based amendments. And this is biochar, but it's not to the exclusion of other amendments. So I think makes it a little more what's the word I'm looking for? applicable in different scenarios. But that has shifted to out of interim and into actual practice. But what I have struggled to find is whether or not the New Mexico NRCS has approved that practice, because there's the guidelines from the NRCS, but each state-run agency is able to say, yes, this applies here. This is something that we'll fund, and or to not do that. And well, there isn't the same kind of democratic voting process on this as there might be for other things. I do think that influence from the land managers in a different NRCS agents area will influence what they want to make sure is approved for the people who are interested in doing things. If it doesn't even cross a person's desk and they're not sure that anyone would use it anyway, and they have a million things to do, I think is always the thing. Why go through the process of, and I mean, I'm extrapolating and speaking for people who are not here, so forgive me if this isn't directly on point, but just like for like spaciousness for those the folks who work for the NRCS, like if it were me and nobody in my constituency was interested in a practice, or I didn't know if they were, I probably wouldn't look that deeply into it. So I do think that that like folks need to communicate to their NRCS agents what they're interested in. And so that I feel like it is a kind of a two-way street, Rosa. And I would love to know, since you asked the question, if Catie or Sanna have heard about this at all, because I was on the internet for hours looking. I was like, okay, I know that this practice exists, but have we approved it in New Mexico? So that's been something that I've been trying to figure out. And it doesn't seem like anyone's chomping at the bit to say, yes, I know. So
what I have experienced is that NRCS agents, especially when they come to NMSU for extension interagency communications, the agents that I've talked to have been really interested in biochar and wanting to know more because they've gotten questions about it. But again, if it hasn't been asked a lot, it hasn't pushed forward onto the top of all the other things that they need to manage. And so there's been some information about it. I'd be willing to bet that it's of interest to NRCS agents, but they have not had a lot of time to learn about it yet.
That definitely reflects some of the things I've heard from NRCS agents. Sanna, did you have something you want to add?
Yeah, I just kind of like a final thought from my side on this one is that even if biochar hasn't been researched quite that much for our soils here in New Mexico than some other places, I think there is enough information to indicate that it can be beneficial. If you want to try it, don't let it stop you that we don't have quite all the research in place. You can definitely try. You can start small. And if you are a small business, there is the New Mexico Small Business Association, via which you can get help from universities and the national labs in New Mexico to actually test things for you. So you can contact them, and I have had projects with them. I don't know if Catie has, and yeah, she has. And so those are things where you can get help. And I think there is a really good comment from Best about how you can get information about things from your local DC. So
when you mention about these, that institutions can test things for you, it comes to mind that couple folks that I interviewed, they came up with suggesting a pilot plan, like in New Mexico or specifically northern New Mexico. Like they would like to know that some farmer or land manager has implemented biochar or like biochar production or biochar application, and that this is like in the local and they have like one reference, one example. And if like we already if we discover that we have those amendments incentive, I'm sorry, authorized in Northern New Mexico, that person could already apply for that, and that person could know the process, and then the person could know the process for the application for the funding, but also the process of production of biochar in the context of Northern New Mexico. That's something that will be also interesting, and that's something that I think the Queer Coalition or any other institution could get involved, see if it's possible, or which elements do we have to create something like that, because for me makes sense.
Yeah, and it is absolutely impossible. In the New Mexico Small Business Association, a farm is considered a small business. So if you are a farmer and want to try something, or have set up a pilot study and want to us, for example, my team, to come and measure the greenhouse gas emissions from your or the pilot site, or the plant performance on your pilot site, yes, you get a project with the New Mexico Small Business Association, and they pay for us to do the measurements for you. So that's how it works. And so, yeah, if you are interested, please reach out.
Yeah,
That's
I love
amazing.
that.
Yeah, me too.
Yeah, and then I'm not sure how exactly this would work, Sanna, but it seems like there might be a role for like supporting farms in organizing, in order to not just have individuals saying like, well, I'm not entirely sure what I'm trying, but to like design a project and figure out how to implement it in different places where people are interested in, and then be able to have you come out and test that. So that it seems like there's a lot that can happen around here.
Yes, absolutely. And they, the New Mexico Small Business Association does have a concept of having like a coalition project where several small businesses come together with one goal, and then exactly as you described, testing on many sites, or testing different aspects of it. And yeah.
Yeah.
But the applicant has to be the small business. But then, but me as a researcher at the National Lab, or the New Mexico Small Business Association, they will help you in the process.
Excellent. Thanks, Sanna. Catie, do you have any closing thoughts that you'd like to add?
Reiterate that I need to make a trip north more often.
Thank you very much, Wes, for the link.
Yeah, we've got link up there. Okay, so we're pushing 10:30 already. I was like, wow, I can't believe how fast that went, actually. Thank you so much, Catie, Sanna, and Rosa. It is so wonderful to get to be in space with you and hear your thoughts, and hear what happens when your thoughts all get mixed together. New things, whole greater than the sum of its parts. I've learned a lot, and I'm really excited to see what happens next, as we continue to look at the role of biochar in New Mexico.